only one perfect solution, but there are clues that will try to trick our team.
Hello there everyone, my name is Crazy Caleb and welcome to Malfunctions. So this module is the sequel to the module called Functions. It will work very similar in the same kind of concept, so I would advise you to know how Functions works beforehand, but this module has a lot of different quirks on its own that makes this module so unique. So let's get right into this. So on this module, it's currently going to be read, and the difference between functions and malfunctions, and let me pop up the manual here. Functions here. I do have the optimized, but don't question it. So the difference between this is that, as you can see, it's currently a red background. Functions normally has a gray background, and what we have here is we have these top numbers, in this case where the letter would normally be, and the two numbers A and B in this case, they're no longer down at the bottom. They're now at the top, and the numbers are in the middle here. So this is going to be the big difference here. So let's take a look and let's see exactly what we need to do with this module, and let's see what's going to happen here. Warning, this module is prone to malfunctioning. When it is initialized, it will randomly select either +1 or -1, assigning that number to x. Then it will randomly select one of the three following quirks. Adding x to the final query result, the result will not go below 0. Moving on the list of functions by x after each query, wrapping around it from 0 to 35 or vice versa as needed. Only the first query function is needed to figure out what the final function will be, and adding x to each variable. Variables cannot become 0, nor can they go above 9,999. This is what's going to be happening here. So now what our goal is here is we need to figure out our initial query function, and this is going to be done by taking a look at this list here. So list 1 is the functions here, and we have a lot to go through, but it's not as bad as you think. So what our goal is here is we're trying to figure out first off what our initial query function is, and what exactly is also malfunctioning with this module here. And it's going to be one of these three quirks, which is going to be very important for us to note down. It's either adding x. So for example, if I were to query, for example, 2236, what would happen instead is it would query under the result of 23, 37, or 21, 35. In this case, adding 1 or subtracting 1 to our query to our query here. In this case, each variable. It has the possibility of, for example, say, if this happens to be like, for example, 22 by 36, and then what happens is if it was the, for example, larger modulo smaller, 36 modulo 22, 36 mod 22. It gives us the result of 14. What can also happen here is this could be simply 15 or 13, in this case, adding x to the final query result. That's what's going to be happening here. And then finally, the weirdest one of them all, moving on the list of functions by x after each query. So what could happen here is that the result that you get is perfectly fine with what you have first queried here, but what could happen here is that we can go, for example, from highest digit down to a plus b modulo 12, down to a times b, or up in the direction of a modulo 10 cubed plus b modulo 10 cubed, to lunar addition, to absolute value of 10,000 minus a times absolute value of 1,000 minus b. So it can go in a wide variety of different directions, and that's probably the one that gets the people the most, is the fact that it can go in different directions. But overall, these guys are not that hard to spot, and what I'm actually going to do now is I'm actually going to begin by querying a couple numbers here. So what we want to do is we want to look for possible answers here, and we need to make sure that we also consider the possibility of the quirks coming into play here. So we need to consider if we were to query, for example, 2236, which I think I'm going to do right now, 2236, and by the way, you have to press the comma in order to get the second number in here. Then all you simply do is hit query, and you get a result. So now, with this in mind, we have a couple different possibilities. First things first, moving on the list of functions by x does apply, it's not going to happen immediately. You won't be able to notice it, and you simply just want to look for your first query function here. But keep this in mind that it is going to be that the first query function that you get, if you happen to get the moving on the list by x, it's not an offset from a previous square that you need to consider. The first one that you get is the first one that you're going to be working with. It's not like, for example, say you started on 17 as your first example, you're not going to go back to 18. It's simply just going to be 17 that you get. That's the way that this works. So now we need to consider the fact that we get the result of 9 here down at the bottom from this query. So what could happen here is that we have the possibility of, for example, saying the query was 2135. so 2135, 2236, which is just the normal query that we had here, or 2337. We also have the possibility of considering it being 8, 9, or 10. And we also have the possibility of considering moving on the list, which is why multiple queries are likely to happen. But for the first bit of this, what you're essentially going to want to do is you're going to want to go through these functions, and you're going to want to just try and get results that get somewhat close to this answer. In this case, if it was +1 or -1. So let's just start plugging things in, and we can kind of eliminate a lot of these because a lot of these happen to have to do with big numbers in this case, like multiplication. You can get rid of any sort of multiplication, especially with these numbers, just because it's not going to happen. So the absolute value of a minus 3 times absolute value of b minus 3, well, that's just not going to happen because of the fact that it's going to be large. It's going to be multiplication, so it doesn't matter. Larger modulo smaller. Now, in any of these cases, does it happen to get like a 10 or a 9 that we need to get? So in this case, 37 minus 23 is 14. And actually, one of the things that you can immediately realize here is that all of these results for modulo are going to be the exact same. In this specific instance, anyways. So larger modulo smaller is not going to work. 10,000 modulo larger. Let's see what happens here. 10,000 modulo larger, in this case 36 would be our larger one, or 37. So now in cases like these will actually have different answers here. I'm going to start with 37. So 3,700, and minus 370. That's going to result in a 10. This is possible. This actually has the possibility of happening, but remember, I did this with 37, and 10 is a different answer. Only one of these quirks can apply, so this is actually not going to work for this instance. Would 36 happen to work, though? 10,000 minus 360,000, 3,600, minus 360. Nope, plus 360. Minus 36. No, that's not going to work for that one. And then let's try 35. Well, that's already not going to work because of the fact that we know it's going to be either, it could be either a 5 or 10. But if it was a 10, then that would mess up this whole thing, so it's not this equation here. It did not give us a result of 7, and 7 is not one of the options that we can have if it was +1 or -1, so that's not going to be considered. If you happen to get that equation, every single result will return as a 7. That's going to be the way that module works. Or in this case, if you need to consider the fact that it's going to be a +1 or -1, that's going to be a little bit helpful. So larger divided by smaller. Oh, and one other catch that I forgot to give about this module. If, when querying, both displayed input numbers are the same, either input number is the same as a number queried in the last non-striking query, or either number is 0, a strike will be given. So you have to use different queries each time. And it makes sense to use different queries, because what you want to do is you want to note down each query that you get, but make sure you change the numbers up in some manner or fashion. This can be simply just increasing these numbers by 1, for example, or just doing a wide variety of different queries. Trust me. So let's get back into this. And most of these are just instructions of how you essentially input the numbers. Now, one other thing that I should note down is any calculated answers, including the final answer necessary to disarm this module, will only use the 12 most significant digits, even though that is rare to happen, and will have all decimals drop only right before the display, unless a function mentioned otherwise. Pressing the comma will have no effect once it is displayed, and pressing query will have no effect until the comma is entered, or if it was just pressed. So, that's going to be important. We're going to be dropping all decimals for our final answer. Just keep that in mind, because there is some cases of division that just will give you like a bunch of decimal results. So let's keep that in mind. So let's continue on. Larger divided by smaller modulo 10. In this case, if we were to do any of these, for example, let's just do the largest one, 37 divided by 23, it's going to give us a wide variety of gibberish. In this case, it's going to give us 1. So this is not going to work. Triple the number of odd digits, of odd numbers. Triple the number of odd numbers. In this case, we only have 1 odd number present in this query. However, there is the possibility of us getting, of us having the 23 and the 37. And that would actually return the result of 9. As well as the 2135. We don't know exactly which direction it's going, but this is actually a possible query that we could potentially use here. So I'm going to mark this in blue, because of the fact that there is a possible quirk happening here with this. this. We don't know if this is actually going to be occurring, but it is possible that it could go in either direction. It could just simply not be a 2236, because that would only result in one odd digit, and what odd number in this case. So that's going to be what we're looking at here. Next up, 10 minus the absolute value of digits in A minus digits in B. In this case, that's just going to simply be 2 and 2, because it's the amount of digits in each of these values here. And we're going to be subtracting 10 minus 0. That's going to be as simple as that. So this actually is another possible option because of the fact that regardless of whatever we input in here, it has the possibility of the answer itself being minus 1 or plus 1. Or no. Or it has the possibility of it not working like that. That's not how that works. That the result would have returned as 10 in this case. Or actually, yes, it could actually be minus 1 because of the fact that it could return as 9 when the answer originally was 10. That is a good point. So that actually is possible here. Next up, sum of digits in A times sum of digits in B. In this case, this is going to be 4. This is going to be then multiplied by 9. 4 times 9 is 36. Not going to work. A times B, not going to work. A plus B, modulo 12. Let's see what that gives us. 22 plus 36 is 58. Modulo this by 12 is going to be 10. That is indeed possible. What about the other two equations? 37 plus 23. Modulo this by 12. That's going to be a 0, not possible for that one. 35 plus 21, modulo this by 12, is going to result in 8. Now, there is actually quite a few possibilities here, but given the fact that 22 plus 36 did give us 58, and we modulated it by 12, gave us a 10, that is a possible option here. Simply because of the fact that it could be just the normal equation that we had here, and it could be a plus 1 for the answer. That could be the way that this works, or minus 1. So that's a possibility here. Mark that here. Highest digit in this case represents 6. That's not possible, so we can get rid of that. And as you can see, this takes a while. I'm going to simply just now get rid of everything that has some sort of weird cracked up multiplication here. Times larger modulo smaller modulo 8. Let's see if that works. Larger modulo smaller. So 36 modulo 22 is 14. Modulo 8 is going to be 6. I don't think any of that's going to work. 35 minus 21 modulo 8. And then 37 mod 23, it's going to be the exact same results. No, that's not going to work. Number of different digits. Now, one important thing to note down is that when it refers to different digits, in this instance, what we have here is we have 3 different digits present. In this case, 2, 3, and 6. It's not going to count duplicate values, but it will only count 1 for that. It's essentially distinct. But essentially what we're going to hear, essentially what's going to happen is there's going to be 3 different digits. This would return as 3, but this is not going to work. So that's not going to work. It wouldn't work for any of the rest of the queries. We don't care about that. Smaller minus larger modulo smaller. So if we were to do 36 modulo 22, we would then do 22 minus 14. This is a possibility of actually working here. As well as lunar addition. For those of you who are wondering, there is an appendix of math and other stuff down here. And lunar addition works as addition, but in each place, it takes the higher number instead of adding. So in this case, 184 plus 229, it's going to take the 2 for the first position, it's going to take the 8 for the second position, and it's going to take the 9 for the third. In this case, that's going to give us 289. It's comparing two numbers together. And in this case, if we were to do lunar addition, it would result in a 36. Not going to work. And then A modulo 10 cubed plus B modulo 10 cubed, not going to work. I can already tell that it's going to become a 2 cubed and a 6 cubed. And that's going to be a lot larger than 9, so we can get rid of that. Now, I do believe we considered this as an option. This is indeed present. This is indeed actually valid here. We don't know which one we're going to be looking at yet. Now, the number of different odd digits. Odd digits works like, in this case, if we were to query, it's just not going to work. Because the maximum amount of odd digits that we would get in one of the other 2 queries would be 3, and it's not close to the answer of 9, so that's actually going to be gone. So let's get rid of that one. Then we have A plus B times 10 plus, well, that's already not going to work. We can get rid of this. A plus B, not going to work. A times B divided by ports plus 2. It'll be A times B divided by 2. So 22, times this by 36, I can already tell it's going to be greater than that, so we can get rid of this option. a times b modulo 10. A times b modulo 10, so 22 times this by 36, 792. Let's try the other options. 21 times this by 35. Okay, not possible. And then 23 times this by 37 is going to be 851. Not possible for either of those. Number of different digits missing. Now, what we need to consider here is how many different digits we're missing. So in this case, we're missing 0, 1. We've got 2, 3. We don't have 4. We don't have 5. We don't have 7, 8, and 9. That's only going to give us 7. That's not in the range of where we need to be in with regards to solves. So let's just keep this in mind. And neither is it going to work for any of the other ones because this is exactly the same amount of digits present. In this case, there's 2 3s, and there's only going to be 4 here, which actually decreases the result. So not going to work. Larger modulo smaller times smaller, we can get rid of that. A plus b squared, we can get rid of that. 11 minus twice the number of non-2-digit variables. Well, that's 11 minus 0, so that's going to be 11, not in the range that we need to have here. Absolute value of a minus 2 times b. Let's see what that gives us. So 2 times 36, 72. 22 minus 72 is going to give us negative 50. Not going to work. A times b modulo 73. 22 times 36 modulo 73. 730. That's not going to work. I can already tell. Let's get rid of that one. Digits in A and B times 1500. Nope. 3 plus the number of numbers over 2500. No, because it's always going to result in 3. A squared plus b. Nope. Larger divided by digits in both A and B. Digits in both A and B. That's going to be 0, so that's not going to work. Nope. A plus b plus concatenated serial number digits, which in this case, if we concatenate these guys, that's going to result in a 1070. So that's already not going to work. Next, 8 minus the number of numbers below 100. 8 minus 2 is going to result in 6. That's not within the range of the possible numbers here. A modulo 50 plus b, that's not going to work, and larger divided by smaller, not going to work. So already we have a lot of options crossed off here. I'm sorry this took so long. Next time, hopefully we will go through this a little bit faster, but now what we need to do is we now need to do another query for this. So let's do, for example, let's do 50 and 80. 50 and 80. 50, comma, 80. Let's query that. And this gives us a result of 9 as well. Okay, interesting. 50 and 80. Now, I have reason to believe that what we have here is not a changing answer, but perhaps a changing query or perhaps a changing function here. So now what we want to do is we want to focus on these. Smaller minus larger modulo smaller, which in this case actually still has the possibility of working here. I should have considered that. Triple the number of odd numbers. In this case, if we were to do 49, so we have the other possibilities of there being 49. So 49 and 79, 49 and 79. That still has the possibility of being there. And then 51 and then 81. That's going to produce 3 as well. A plus b modulo 12. If we were to do 50 plus 80 modulo 12. That's still going to produce 10, still has a possibility. I need to do a different query, because this is not going to work. I need to do something that is going to be very helpful for us. So let's cancel this out. We don't really care about that. Let's do something simple. Let's do 2 and 4. It produces a 5. Okay, interesting. Now with 2 and 4, we have the possibility of there being a 1 and a 3, and a 3 and a 5. So now, with this changing, I do believe that actually what is happening here is that we do have, potentially, it's going to be either, I don't think the function is changing. I think it's safe to say that the function is not changing. And it's safe to say that this is also not number 6. Because 10 minus the absolute value of digits in A minus digits in B, that would be simply a 1 minus 1, which would be 10 minus 0. This is not a function anymore, so we can get rid of that option. Triple the number of odd numbers. Now, With this in mind, what would have to happen here with this is if we were to triple the number of odd numbers, what would have to happen here is not only would it have to be one of the functions that we would have to move essentially in our result, essentially, changing the variables themselves, but what would also have to happen here is that the answer itself would have had to be swapped. It would have to be essentially a 6 if we were to do this. So this is not going to work here because of the fact that 2 quirks would have to apply here when only 1 is actually going to apply. So this is not going to work. So let's just get rid of this. Now, a plus b modulo 12. Now, one of the important things that we can recognize here is the fact that also number 16 doesn't apply as well. If this were to be true, smaller minus larger modulo smaller, now in this case, if we were to do smaller minus larger modulo smaller, in this case, 4 modulo 2 is going to result in 0, and it's going to end up being 2 minus 0, which is going to be 2. This function does not work, so this is not going to work, so we can get rid of this. And now, I do believe what is happening here is instead of this happening, instead of the variables themselves changing, our answer is changing. Because a plus b modulo 12, if we were to do 2 plus 4, which would give us 6, this would be minus 1 away from this point. And if we were to apply the exact same thing with this 22 and 36 from beforehand, in this case, if we were to subtract 1, that gives us a 5. Now, if we were to do 22 plus 36, remember our answer from the previous one was represented by this 9 here. It does have the possibility of it being 10, and then it subtracts 1. So we have to do, we can also consider 11 in here too. So modulo this by 12, plus 12. If we were to subtract 1, this would also give us a result of 9. Now this does give me reason to believe that this is going to be our function here. So this is going to be the one that we're going to use. So our answer itself was not, so the function itself was not changing, but instead the x to the final query result was what was changing here. So we're going to note this down as x equals -1. And I'm going to try a couple more queries just to make sure that this is correct. So for example, let's do, if we were to do 3 and 5, for example, what this result would give us? This would give us a 7. It does indeed. Yep. If we were to do 1 and 2, for example, no, we've already queried 1, for example. We haven't queried 1, so we were to do 1 and 2, 1 and let's do 1 and 9. This would give us 9. It does indeed. Okay, this is safe to say that this is our function here. So now what we need to do is we need to get into the solving process of this. So these numbers at the top is what we're going to be using for our final function here. And the way that this is going to work here is what we need to note down was we needed to note down x is worth -1. This is very important for the second part of this process, where what we're going to do is we're going to get a letter adjustment here. So in this case, we're going to get Quebec. Quebec is going to be the rule that we're going to look at here, which is going to be representing this edgework condition. E, R, I, or S in the serial number. Let's take a look. E, R, I, and S. No, none of those are present in there. So, what this is going to return as is this is going to give us a false equation here. So this is going to be false. However, there is a bit of a catch that we need to note down here. Find the query function being used by the querying one or more times and using list 1. So in this case, we use list 1 to find our functions. Then use the letter on the top row along with table 2. So in this case, we're using Quebec. We're finding the condition. So to find your final function, determine whether that letter's condition is true. In this case, we determined that it was false. Then use the proper value that is x rows away. -1 means up, +1 means down. Using that offset found to find the final function. Wrap around as necessary in both cases. So what this essentially means here is that just because we found Quebec, and we have the value of -1, -1 represents going up. Now, in some cases, this -3 won't necessarily be -3 the entire time. What this wants us to do is we want to do Quebec as normally. We want to make sure if we can check for this being true or false. But what we want to do here is we want to apply the transformation that we got from the value of x. In this case, we're going to go up, or subtracting 1, and we're going to get the value of -3. If this happens, if this case happened to be true, in this case, if there happened to be like a Romeo present in the serial number, what this would do is this wouldn't be +1, this would be +2. And now what we're going to do is we're going to get this offset. We're going to apply this to the current list of functions here. So we're going to go from 9, and we're going to subtract 3 from this. In this case, we're going to go down 1, 2, 3 to 6 here. And now we're going to solve this module. We're going to plug the 3, 3, 8, and the 15 at the top of the module into this function here. So let's do this. 10 minus the absolute value of the digits in A minus the digits in B. Note that left and right represent A and B respectively. So now what we're going to do is we're going to do the absolute value of the digits in A, which in this case represents 3, minus the digits in B, which is going to be 2 minus 2. So 3 minus 2 is going to be a 1. It's already absolute value, it's already positive. And then we're going to do 10 minus 1, which in this case is going to give us a result of 9. We're going to hit clear, we're going to enter in 9, and now with this result in the bottom function here, we're going to hit the submit button, and just like that is a solved module. Sorry this took so long to explain. I wanted to make sure that I got everything covered. I will do this next example a little bit faster, and hopefully we actually get some of the some different functions here, because we were able to get the result of itself, the final result actually changing here. I might do 2 more just to make sure, just to see if I can get the different results. But essentially what's going to happen here is you need to make sure that you understand that there is the possibility of the function actually moving around here. And just make sure that you also consider that as well. So that's why I like to consider each of the individual starting points. It can take a while to do that, I understand. So that's kind of the way that this is going to work. So let's get right back into another example here. But just remember that only one function, that only one quirk is going to apply. That's the key message here. So let's look at another example, and we have to go back again. Cool. So I like to start off with 22, 36. That's kind of just my normal get-go. Obviously, there is an optimizer for this manual. If you want to use the optimized, be my guest. But I like to start off with 22, 36. And we get a total of 322. Now, there's a lot of possibilities that we can do with this. But one of the things that I might want to look at here is, say, for example, 22 times 36. What's that give us? And that's not going to be it. Okay. So, there is definitely a lot that we can do here. Okay. It's not lunar addition either, so we can already rule out a lot of options here. It's not larger modulo smaller anything. It's not 10,000 modulo larger. It's not 7. Absolute value of A minus 3 times absolute value of B minus 3. Now this could actually be it. Let's take a look at if it was. And what we want to do is, in cases like these where we actually might have multiplication present, we kind of want to get close. I'm not really going to worry about the other additional queries, in this case being 2135 or 2337 at the moment right now. What we want to do is we want to get close to 322. That's going to be the way that we're going to determine this. And in this case, with the number this large, I'm not really going to worry about the fact that it might be a +1 or -1. I'll know when I see it. So let's get right into this though. So it could be absolute value of A minus 3, in this case being 19, times absolute value of B minus 3, which is going to be 33. Nope, not going to work. Too far off. Larger divided by smaller, modulo 10. No. Triple the number of odd digits, not going to work. 10 minus, that's no. Some of the digits in A, that's too little. A times B, we already determined that's false. A plus B, nope. Highest digit is a no. A modulo 10 cubed plus 6 modulo 10 cubed, that's not going to work. Lunar addition doesn't work. Absolute value of 10 minus A, 10,000 minus A. This is a very large one. You'll know when you get this one, trust me. From experience, I can say that for sure. So not going to work. Especially if you're using low numbers like I am, 22, 36, you'll know. Larger modulo, smaller, modulo 8, nope. Number of different digits, nope. Smaller minus larger modulo smaller, nope. Number of different odd digits, no. A plus B times 10 plus absolute value of A minus B, no, it's wait, maybe. A plus B times 10, 22 plus 36, 22 plus 36, multiplied by 10. No, that's not going to work. A plus B, nope. A times B divided by 4 plus 2. We have divided by 4. A times B divided by 4. 22 times 36 divided by 4. No, not going to work. A times B modulo 10, nope. Number of different digits missing, nope. Larger modulo smaller times smaller, ooh. Okay. So this is actually possible here. So we do larger modulo smaller times smaller. So we do 36 minus 22, get the result of 14 times this by 22. Ooh, this actually is possible. This one actually might be a solution here. So let's actually take a look at the other possibilities that we have here. So we have 21, and we have 21, 35. And then we also have, for example, 23 and 37. Let's actually try 37 because we need to go a bit higher. So 37 modulo 23 is going to give us the exact same result of 14. But if we do 23 here, this gives us the result of 322. Bada bing, bada boom. So now, what we've determined here is we've determined that this is a larger modulo smaller times smaller. We've determined our function. I don't think any of the other ones, just to make sure. A plus b squared, nope, that's too high. 11 minus twice the number, nope. Absolute value a minus 2 times b, nope. A times b modulo 73, nope. A squared plus b, no. 22 times 22, that's going to be too high, I think, yeah. 3 plus the number of numbers, nope. Digits in a and b times, no, that's way too high. Larger divided by digits in both a and b, nope. A plus b concatenated concatenated serial numbers, 864, already too much. 8 minus number of numbers below 100, nope. A modulo 50 plus b, larger divided by smaller. Yes, this one is very apparent that this is going to be our answer here. And what's happening with this is essentially what's going to be happening here is we have 22 and 36. And instead what's happening here is that the results, the queries, the queries to each variable is being increased by +1. So x is going to be equal to the positive value of 1 here. Now what we're going to do is we're going to go down to Quebec. We're going to go compare this position here. So in this case, E, R, I, or S, the exact same condition that we just got here. Do we have that in the serial number? E, R, I, and S. Now, we don't, as you can see here. And now what's going to happen here, this is a false, but now x is equal to 1. And now I'm actually able to show off how this works. Perfect. So, +1 means down. In this case, we had a positive value of 1. So now what we're going to do is from this -3, we're going to go down 1 space, and this is going to give us the result of -2. Now, from this position of 23, this was our starting function, we're going to go down -2 here. And by the way, you can obviously do as many queries as you want. For example, if we were to do, let's just do 2 times 4, let's do 2, 5. Agree that. That gives us the result of 0. Larger modulo smaller, 5 modulo 2 times smaller, in this case being 2. That's strange. Maybe I'm looking at something else. Oh no, right, you're looking at a 6 modulo 3, in this case actually giving us a 0. Right. That's actually very important to note down. The function itself did actually change here. So instead of 2, 5, it would be a 3, 6. That's the way that this works. And the larger modulo of the smaller is going to be 6 modulo 3, which is going to result in 0. Anything multiplied by 0 is going to be 0. This makes sense. Okay, so now we've got -2 here, so we're going to go from 23, we're going to go down twice, and in this case, this is going to give us the final result of a times b modulo 10. So all we're simply going to do is we're going to multiply these two numbers at the top, 400 times 13, modulo this by 10. In this case, we're simply just going to take the last digit of the number here, clear the answer, input 0, and just like that is a solved module. So I got 2 of the 3 quirks. I doubt I'm going to get the third one, but essentially it's not too bad of a thing to understand. You'll know something's off when you're getting exact answers, and that's kind of the way that you'll be able to determine that, because it's always going to be an exact answer that you're going to get. However, you'll know when you see it. So, but as always, thank you guys for watching. Remember to stay crazy, stay cool, and I'm sorry it took so long to explain this one. And as always, thank you guys for watching, and have a great day. Bye-bye.